Okay, so this video is going to cover the information that will be the last thing that your quiz will cover. So we're going to talk about finding all zeros. So finding all zeros is something that we can use synthetic division to do. We learned in the last lesson that when you do synthetic division with a number and you get a remainder of zero, that means that that particular number is a zero of the function. So what we're going to do is use that fact to solve polynomial equations like this one, where we don't know any of the zeros to begin with. So what we're going to use is this thing called rational zero theorem, to figure out what the zeros are going to be. So the first thing that we're going to talk about is what rational zero theorem is going to tell us. So using this particular polynomial, notice that if I tell you that the zeros are these three numbers, -5/2, -3/4, and 7/8, it doesn't have any whole number zeros. It doesn't have any integer zeros. So all of the zeros are these random fractions. So how on earth, if I don't have a list of numbers to choose from, how on earth would I come up with those three numbers to even try in synthetic division? Well, that's a good question. Rational zero theorem is what helps us come up with the list of numbers that could be possible zeros. So here's what you're looking for. Notice that all of the numerator numbers, 5, 3, and 7, they're all factors of this end number 105. Look at all of the denominator numbers. 2, 4, and 8 are all factors of the leading coefficient, which is 64. So what we can do is we can make a list of our possible rational zeros by figuring out what are the factors of the end number and what are the factors of the beginning number, and then writing all of those factors as fractions. So it's going to give us a list of numbers that could possibly be the zeros. Now, once I have that list of numbers, I have to test them using synthetic division. However, it's going to give us a smaller list of possible numbers than if we were just to start randomly guessing values. So what we're going to do in this first problem is use what we just talked about, and we're going to come up with the list of possible rational zeros. So the first thing that you're going to do is figure out, well, what are the factors of this last number, which is 12? And so 12 has several factors. They would be 1, 2, 3, 4, 6, and 12. 1 times 12, 2 times 6, 3 times 4. Also notice I included a plus and minus for each one of these, so there's a reason why for that. Positive 12 can be made one of two ways. You can multiply positive 1 times positive 12, or you can multiply -1 by -12. So both of those have to be included, both the positive and the negative factors. Same thing is true with 2 and 6 and 3 and 4. So we're going to call that list of numbers our p's, factors of the end value. We're then going to list the factors of our leading coefficient. Now this one is easy because the leading coefficient is 1. So there's only one factor of 1, and that is the number 1. So we're going to take that fact and we're going to write this list of numbers called our p's over q's. This is going to give us the list of values that could possibly work using synthetic division. So all you're going to do is take every single p and you're going to write it as a fraction over every single q. Now in this particular one, every single one of these numbers, 1 divided by 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1, they all just give me that same exact list of numbers. So I'm actually just going to end up recopying the list that I already have made. So what I know is these are the only possible rational zeros for this function. So I know that when I try numbers in synthetic division, I don't need to try numbers like 5, or numbers like 7, or numbers like 1/2, or -3/4, or 2/3, because none of those numbers that I just said are on my list. These are the only possible ones that could work using synthetic division. Now, as the numbers get larger, So notice in this particular one, this 10 is going to have less factors than the 12 did. So my factors of 10 are numbers like 1, 2, 5, and 10. So we're going to make the same list that we did over here with our q's. So we're looking at factors of the first number. Now this one's going to have more than the last one did. So my factors of 4 are 1, 2, and 4. When I make my list of p over q's, this one is going to be longer than the previous list, because not only am I going to have to divide 1, 2, 5, and 10 all by 1, but I have to divide each of them by 2 and each of them by 4. So it's going to make a longer list of numbers. If I take all of those values and divide by 1, I get the same list of numbers, 1, 2, 5, and 10. If I divide every single one of them by now 2, sometimes you're going to get values that repeat themselves, so you don't have to list them a second time. So every p divided by 2 would give me plus and minus 1/2. 2 over 2 is 1, that's already listed. 5 over 2 is 5/2. And 10 over 2, which is 5, is already listed. We're going to do the exact same thing with the number 4. 1 over 4 gives me plus and minus 1/4. 2 over 4 is 1/2, it's already listed. 5 over 4 gets listed, 5/4. And 10 over 4 reduces to 5/2, it's already listed, so I don't have to list it again. So notice that this gives me a little bit broader of a range of numbers to try. However, looking at this list, you know that these are the only possible ones that could work. So I don't have to worry about trying numbers like 3 and 4 and -6 or -1/3 or 3/2 or anything like those, because they're not on my list. These are the only ones that could work. So you start out being able to, or not knowing which numbers to try, and you just be grabbing numbers out of the dark. Now we actually have a set list of numbers that could possibly work. So now let's actually see what are we going to do with those numbers once we find them. So here's what we're going to do. We are going to take those numbers and we're going to see, does the number work or does it not work? And the way we're going to try that is by using synthetic division. So first thing you're going to want to do in any problem is use rational zero test. So you're going to make your list of values. So in this one, let's do our p's. Factors of 6 would be 1, 2, 3, and 6. Factors of your leading coefficient would be 1 and 2. And then my p over q's. We're going to do every p divided by 1, every p divided by 2. So I'm going to get my first list of numbers, everything divided by 1, and then now everything divided by 2. So we add on a 1/2, we add on a 3/2. 2 over 2 is 1, already listed. 6 over 2 is 3, already listed. So these are the only numbers that could possibly work using synthetic division. So what are we going to do? We're going to do synthetic division and figure out which ones work and which ones don't. So I'm actually going to do the work on a piece of scratch paper, and when I find a value that works, I'm going to transfer it to my actual paper. So on my scratch paper, let's say that we decide that using synthetic division that we're going to try and see if the number 2 works. So I'm going to try 2. It may work, it may not work. So if I drop my 2 and I do my synthetic division, we multiply and get 4. We add and we get 7. We multiply and get 14. We add and get 3. We multiply and we get 6. And lo and behold, it works because I got a remainder of 0. So what does that mean? That means that the number 2 is one of my answers. It's a 0. So what do? Do I have to keep doing synthetic division? The answer to that question is no. So notice that this problem started as a cubic. If we do synthetic division once, what's remaining is now a quadratic. 2x squared plus 7x plus 3 equals 0. Now, you don't have to keep doing synthetic division because we know other methods in order to solve a quadratic. You can factor, you can do quadratic formula, you can even do completing the square. So there's no reason to keep going with this using synthetic division because I have easier methods that I know are going to work. Now this particular one is going to factor, so I'm going to factor it. My two factors here, two things that make 2x squared are 2x and x. The things that make 3 are 3 and 1, so you have to situate them correctly. The 3 is going to multiply by 2x. The 1 is going to multiply by x. And that's how I'm going to get my 7x in the center. So my last thing I do is list my zeros. So from the first parenthesis, -1/2. From the second parenthesis, -3. And then I also want to list the number that I got when I did synthetic division, and I got a value of 2. So there are my 3 zeros for this function. Sometimes when you do synthetic division, you get lucky and the first number you try works. Sometimes you do synthetic division a few times before you find one that works. So before you throw your pencil down and say, this problem, I can't solve it, you have to try all of these numbers before you make the statement that it doesn't work. You have to try all of them. So don't come back to class and tell me, well, I did this problem 1,000 times and I never got one that worked. The first question I'm going to ask you is, did you try every number on the list? Because if your answer is no, that means that you didn't try every possibility that could work. And perhaps one of the numbers you didn't try is the one that actually works. So we're going to go to the next problem, and we're going to do this one. So the first thing we're going to do here, again, is list our P's and Q's. Now, 42 has a lot. 42 is divisible by 1, by 2, by 3, by 6, by 7, by 14. I lied, by 14. Let's see, 21. And 42. 1 times 42, 2 times 21, 3 times 14, 6 times 7. So that's a lot. Your Q's, factors of 2 are 1 and 2, so that's a short list. And then you have to make your list of your P over Q's. Now, if you take all of those numbers and divide by 1, you're going to get the same list of P. So I'm just going to list that as all P's. So every one of those lists, every one of those numbers on that list is going to be a possibility. And now I need to divide every single one of them by 2. So that's going to add on plus and minus 1/2, plus and minus 3/2, plus and minus 7/2, plus and minus 21/2. I didn't list 2 over 2, 6 over 2, 14 over 2, or 42 over 2 because they're already listed in my list of P's. Now, if you're trying to make a determination, how do you figure out what number I should try first? The last numbers I would try are the big ones. I wouldn't try anything probably from here on out until I absolutely had to. I would first try numbers like 1, 2, and 3, -1, -2, and -3. I'd also try numbers like 1/2 and 3/2 before I extended myself out and tried these bigger numbers. So let's do some synthetic division and let's find out what we have to do in this case, because this one's a little different than the last one. So let's list out all my coefficients. Now notice there's nothing missing. We have a 4th power, we have a cube, we have a square, an x, and a number value. Okay, so from my list of numbers, you got to pick one that you think might work. So if we pick one that we think might work, let's say that we think the number 3 is going to work. I actually have no idea whether it is or not, but we're going to try it and see if it does. So if I drop my 2 and multiply, add and multiply. If we multiply, let's see, -19 and 45 is going to give me 26. And 3 times 26 is going to be way too big. 3 times 26 is 78. That makes this end number way, way too big. So I know that 3 is not going to work. So all I'm going to do is put an X through that so that I know I tried 3 and it didn't work. So we're going to recopy our numbers, and we're going to try to figure out again what numbers work. So say we try the number 2. Maybe 2 will work. Drop my 2, multiply. Add and we get 9. Multiply, you get 18. Add, you get 0. Multiply, you get 0. Add, you get negative 19. And multiply, you get negative 38. So it's closer, but 2 doesn't work because I didn't get a remainder of 0. So I know that 2 doesn't work. So now we redo it and we copy again. There are going to be times when you try multiple numbers until you find one that actually works. So what you can't let yourself do is get frustrated by trying to figure out one that doesn't work. Okay, so let's try negative 2 and see if that one works. So let's try negative 2. Drop the 2 and multiply. If we add, we get 1. We multiply, we get negative 2. We add, we get negative 20. We multiply, we get positive 40. We add, we get 21. And we multiply, we get negative 42, which gives me a remainder of 0. So that means that x equals negative 2 is a 0. Now let's look at what's left. When we started the problem, we had a 4th power. This is now a cubic. I want to get my polynomial down to a quadratic so that I can then just use quadratic formula or completing the square or factoring. So I want to do synthetic division one more time with this answer now and see if I can knock it down all the way to a quadratic. So I'm going to draw my house again, and I'm going to go right from this particular line. Okay, so I'm going to go a little bit outside the box, and I'm going to use the 0 3/2 because it's on my list, and we're going to see if that one works. So I drop my 2, and I multiply. When I multiply 3/2 and 2, we get 3. If we add, we get 4. When we multiply 3/2 and 4, we get 6. If you add, you get negative 14. When you multiply, you get a negative 21, which gives me a remainder of 0. So I found my second 0. It's at positive 3/2. Now, since I've been able to use synthetic division twice, that means that what I have left here is now a quadratic. So let's write that as a quadratic and see what we think we should do in order to solve this. Now remember, anytime you're solving a polynomial, if there's a term in common, you always want to take it out because it's easier to solve when you have the numbers reduced as far as they can be. So here, I'm going to take out a 2 from all of those. And I don't need that 2 because anytime you take out a number value, if you're equal to 0, it actually doesn't matter. So I'm left with this quadratic. Now, you can try as hard as you want to factor that, but it's not going to factor. So you've got two options to use. You can either use quadratic formula, or you can do completing the square. Now, I'm going to do completing the square because I like completing the square. If you like doing quadratic formula, you can do quadratic formula, and you're going to get the same answer I'm going to. You're just going to do it in a little bit different of a process. So the first thing I'm going to do is move this 7 to the other side by adding it. So it's positive 7 over there. Your job is to figure out what number completes the square. Cut the 2 in half and square. 2 divided in half is 1. 1 squared is 1. So I'm going to add 1 to both sides. This now factors into x plus 1 quantity squared, and 7 plus 1 gives me 8. In order to solve, we're going to take the square root of both sides. So I get the square root of 8. Remember your plus and minus when you take a square root. And there's two things left to do. Number 1, subtract 1 from both sides. Number 2, we have to break down this root. It breaks into the square root of 4 and the square root of 2. Square root of 4 is 2, so you get 2 root 2. That gets tacked on the end after the plus or minus. So there are your final two zeros. We started the problem knowing that since this was a 4th power, we needed 4 zeros. We found 2 rational zeros and 2 irrational zeros for my total of 4. So the next part of this is kind of the whole gist of the unit and this lesson. It's called Fundamental Theorem of Algebra. So all this is a fancy word or a fancy way of saying that the number of zeros directly corresponds with the degree of the polynomial. So in this particular polynomial, notice that I have a degree of 5, which means that it's going to have 5 zeros, and those zeros may be zeros that are repetitive. So notice that 2 of the zeros are -1, 1 of the zeros is 2, and I have this imaginary 0 and this imaginary 0. So there are my 5. Notice on my graph, only the real zeros show up. So the imaginary ones are solutions, but they don't show up on a real number coordinate plane. And also notice your multiplicity. At 2, it repeated just once, so we passed through the x-axis at 2. -1 repeated itself an even number of times, twice. That's why we bounce at that particular coordinate point. So all the things that we've talked about kind of come together with fundamental theorem of algebra. And all of this explanation on the bottom is kind of the words of what I just told you. Only the real zeros show up. -1 repeats twice, that's why we bounce. 2 appears only once, that's why we pass through. And then these two things are things that we've discussed in the past. If you have an odd multiplicity, we're going to pass through the x-axis. If you have an even multiplicity, we're going to bounce on the x-axis. So what this brings up then is, if you start a problem, such as, we'll say this one here. Now think about it. If I have a degree of 5, how many times do you need to do synthetic division in order to get it down to a quadratic? You'd have to do synthetic division 3 times. So what you're going to be looking to try to do is figure out 3 numbers from your list that work. So what you're going to do is, when you figure out if one of the numbers works, what you always want to do is you want to test it again and see if it works more than once. Because if it can give you a remainder of 0 more than once, that means that it has a multiplicity. So it's a recurring 0 that repeats itself. So anytime you're doing a problem like this, make sure that when you find a number that works, you go ahead and try it again to see, well, maybe does that number work again, and it's going to make my polynomial reduce down to a quadratic a little bit faster. Also in this one, we're not going to do it, but notice that the x cubed term is missing. So when you set up your synthetic division, you need to plug a 0 in for the x cubed. Don't forget that. You don't want to list out all of your numbers, do your synthetic divisions, and find out that you did every number possible and none of them worked, and the reason why was because you didn't plug a 0 in as this placeholder. Always look for this, okay? Always look for this. Save yourself some stress and some confusion just because you didn't look and notice that the x cubed term is missing, and that's why I need to fill in a 0 in that spot. Okay, so what I would like you to do is I'd like you to do number 2 here, and then we'll discuss it in class. And then if you printed the notes or notice that I have the notes online, this is something that is also a part of this lesson. This is something that we're going to talk about in class together to start class tomorrow. So make a list of other questions that you have questions on. This we'll make sure to cover in class together so you can ask questions as we go. And then again, I'd like you to do this problem here on your own and come back to class with the solutions. If you have questions, make sure you make note of what they are.